All right, 15.1, final learning unit of videos. We're very excited. After this, it's all review. But remember, review is up to you. All right, anyway, the title for this unit is called Sequences and Series. The first one that we're doing is we're doing the sequence. It's a list of numbers that follow a pattern. List of numbers that follow a pattern. So we're going to be finding the pattern, using the pattern, and figuring out the pattern. So here we go. So can you find the seventh term in each of these? So you just have to look at it, decipher a pattern. So this particular one looks like it goes up by 2. So if I do it, this is 1, this is the first term, second, third, fourth, fifth, sixth, seventh. So this is 10, plus 2 is 12, plus 2 is 14. Seventh term. That's it. So the first one that you start at is the first one, and then this is the second, third, fourth, and so on. So number 2, same thing. What's happening here to get to the next one? Well, it looks like I'm adding 3. I don't know about you, but that's what it looks like to me. So this is 1, 2, 3, 4, 5, 6, 7. I'm just spacing it out because I write big. So it looks like I added 3 to get to the next one. So 3 plus 6, 9, 12, 15, 18, 21. Okay, try the rest of these and see what you get. Okay, for this one, it looked like we multiplied by 3, so it was 3 times 3. To get to the next one, times 3 again, times 3, and the seventh term was 2187, as long as I did my math right. Then over here, I did 12 to 6 to 3 to 1.5. We divided by 2, or what we like to say in math, we multiplied by a half. And when we did that, the seventh term was 0.1875. So that is sequences if you just have to figure out the pattern. Now, oftentimes they actually give us a formula to find the nth term of a sequence. And it's pretty straightforward. It's not always A. Sometimes they say T of n or H of n, whatever. They give different letters all the time. But it's always a subscript here, and that n tells you the term number. So A sub 1 is the element of the first, this is the value of the first one, and they're telling you that was the first term. So n is 1, and so on. Nth is the nth element, okay? And oftentimes they'll give it to you, like in this example here. They'll give it to you, it's the nth element. It's called the explicit formula. That's what, when they put it in terms of n, they're giving you the explicit formula. So all you have to do is when you find n, when you want to know what n is, so here they want the first 5 terms, but if they want the 27th term, you would just plug in 27 for n. So for example, they're asking for the first term, the first 5 terms here. So I need the first one. That would be n is 1, so it would be 2 times 1, or 2. A sub 2 would be 2 times 2, okay, because this n and this n here and here have to match. N is n, so that's what we plug in. So A sub 3, 2 times 3, and so on. A sub 4, 2 times 4, and A sub 5 is 2 times 5. Those are the first 5 terms of the sequence. So why don't you go ahead and try 2, 3, and 4. I don't think they're too hard, but try them out. I'm going to do them and come back with the answers. All right, coming back, you'll see how it works. Hopefully you did all right on this one. Remember, this is n, so these have to match here and here. Okay, 2, 2. That's n and n. That should be the same number. Okay, over here, same deal. When we plug it in, A sub 1, 1 goes wherever n went. So here and here. So n matches. These are the 3 n's. These are the three n's. Wherever n is located in the formula, that's where you put it in the equation. So we got 3, 2, 5/3, 6 over 4, or 3 over 2 if you reduce, not necessary, and then 7 over 5. Over here, straightforward, you're just squaring the term number every time, so that'd be 1 squared is 1, and so on. Okay, so that's nice if they give that to you. It's fantastic. Also, something like this. So what is the 15th element? You don't always have to find one element, after the other. You can always just find a specific element. So this particular one, they're asking for the 15th element, so they're asking for a sub 15. So a sub 15 is 15 is n, so 15 goes here. 15 squared is 225. What's the 95th term? Well, then I would just put 95 in for n. So that's what makes these particular ones nice. You have the explicit formula. As soon as you know what n is, what term number you want, you can figure out what the term value is. So in this case, a sub 95, or the 95th term, is 9,025. Cool. Okay, also a possibility, we want to know what term we're on if the element of the sequence is 48. So we don't know what n is, but we know that the value, so we know that a sub n is 48, but I don't know what n is. Hopefully you can see what you can do. It's pretty straightforward. We just plug it in right there. So we know that that's 48, and it's 2n minus 4. And we just solve the equation, and then that will tell us what n is. Pretty exciting, I know. Contain yourselves. 26. So the 26th term of this sequence is 48. So that's the key here. Can you understand the difference between n as the term, like the actual term that you're on, and 48, it's the actual value of the term. So those are the two things that you kind of have to work out for yourself. All right, recursive formulas. So with recursive formulas, one is based on the one before. So as you can see here, if I zoom in a little, not there. What just happened? Okay, there we go. So if I zoom in right here, a recursive formula, if you look at it, 7, 10, 13, 16, 19. Each time you do it, we're looking at the one before. We're saying, okay, we're going to add 3 to it to get to the 10. So we're going to add, I probably should have put the arrow the other way. So from 7, we're going to add 3 and get 10. So it's always based. I have to know this one to figure out the next one. So if I find the first one, I can find the second. And then if I know the second, I can find the third. So the 8th might not be the hardest one to do, right? Finding the 8th might be fairly easy because I'm on 5 already. I just keep adding 3. So we did that on the do now, or like at the beginning. But what about the 95th? That's ridiculous. How do I get to the 95th? Well, it takes a while, is basically what that means. Tomorrow we're going to discuss how to find an explicit formula for it, but right now we're going to talk about recursive formulas. So that just means you have to know what n is. So n is the nth term that we're on. If I do the one before it, that's n minus 1, and the one after it is n plus 1. So for example, okay, if this is a sub 3, the one before it is a2, the one after it is a4. See, n is 3, I subtract 1, 3 minus 3 is 1, and 3 plus 1 is 4. That's all that means. So like this notation, don't let this confuse you. Like this notation here, it just simply means I'm looking right before it. N minus 1 means I'm 1 behind n. Okay? And that's hopefully going to help you out when we do some of these down below. So using this example above, so I got to see it. Using this example above, a sub 1. Okay, well that's the value of the first term. That's 7. That's right up here. Okay, if n is 5, okay, if n is 5, what is a sub n minus 1? Well, a sub n minus 1 is a sub 5 minus 1, or a sub 4. So what's the fourth term? Well, 1, okay. Well, I don't know what the heck just happened. 1, 2, 3, 4. That's 16. What's n plus 1? Well, if n is still 5, a sub 5 plus 1 is equal to a sub 6. So a sub 6 is 1, 2, 3, 4, 5. Well, that's the next one. We said we added 3, so the sixth one would be 22. As long as I can add 3. Okay, that's what recursive means. It means we're going to use the one before it. So in the notation, when you're looking at these, when you're doing these, you're going to notice a subscript here saying n minus 1. Now we can plug in 1, 2, 3, whatever, when we're doing these to find our terms. I find, though, it's a lot easier if you just think about it as the term before. So we want to find the first 5 elements, or the first 5 terms of this sequence. It's a recursive sequence, so it's based on the one before. Okay, so let's think about that. This is saying, now I'm going to write it out first, and then I'm never going to do it again because it just confuses me. If I want a sub 2, then I'm going to plug 2 in for n here. But that's going to be a sub 2 minus 1. I don't know what that's for. Okay, and then this plus 1 is still here. So 2 minus 1, so it's saying a sub 1 plus 1. So that's saying I want the last term, a sub 1, is 5 plus 1, or 6. That is all, okay? So that's all that that's saying. And if you want to get more specific, like when you do it in class, do this out more like this. You may want to, or do it yourself. So if I want a sub 3, it's a sub 3 minus 1 plus 1. So that's a sub 2 plus 1. A sub 2, well, we just figured that out. This is a sub 2, 6. So sometimes it's easier if you're going to do it this way to keep track of a sub 1 is 5. I know a sub 2 is 6. And I need 3, 4, and 5. So just to look over, because we got this whole line of garbage here that sometimes can confuse. I know a sub 2 is 6. So a sub 2 is 6 plus 1, or 7. A sub 4 is I'm only doing this on one example. I got to tell you. It freaks me out whenever I do it. 3, a sub 3, well, I just figured out a sub 3 is 7. 7 plus 1 is 8. You're like, you're kidding me. It's 5, 6, 7, 8, 9. Really? Yeah, well, this is supposed to be an easy example to start, okay? 5 minus 1 plus 1. Excuse me, I'm sick. A sub 4 plus 1. So a sub 4 is 8. A plus 1 is 9. So that's how you do it. So instead of writing this every time, I'm simply going to say the one before. Okay, because it just makes it a lot easier to think about. So I'm going to do this one and then let you try a couple, okay? So if I want a sub 2, so again, I'm just going to keep track. A sub 1 is 1. I need 2, 3, 4, and 5. Those are what I need to be finished. So it's 2 times n minus 1 means the one before n. So 2 times 1. A sub 3, 2 times the one before, so that's 2, which is 4. A sub 4, 2 times the one before, it's right here, 8. Okay, and then a sub 5 is 2 times the one before. So we're on 5, so it's looking at 4, so that's 16. Okay, if you want to plug it in, if it helps you to think about it, plugging in n minus 1 and figuring, doing the subtraction, and okay, it really messes with me, so I'm sorry. Okay, so here we go with 3. Why don't you try this one on your own, and then you'll see the answer in a second. Okay, for this particular one, they did have n here all by itself. So just realize that's still this n that we did before. So this n matches here and here. So a sub 2 is negative 2 times the one before plus 2. Negative 2 times the one before plus whatever n is. In this case, n is 3, and then n is 4, and then n is 5, and it's just awesome. Okay? Okay, you're going to practice a little more in class. I realize these can be a little ecky, but it's all good. Okay? Okay, so when you're doing this one, they're telling you that this is the, this is the one before. Okay, same as the other one where we had a sub n and a sub n minus 1. This is, this is still one bigger than this one, right? So it's a little confusing. It's a little messed up when you start doing the pluses. It's obnoxious, but whatever. So this is a sub 2 is equal to. So in order to get a 2 here, n would have to be 1. So that's the only thing that causes this one as a problem, is because n is 1 here and here. So it's saying a sub 1 plus 1. So a sub 1 is 4. See how it's still the one before, okay? But we're adding 1 to it, okay? So our a sub 1 is 4. Our a sub 2, that's a 4. A sub 2 is 5, and we still have to figure out 3, 4, and 5. Okay, so a sub 3 is a sub 2 plus 1. So it's a sub 2 plus 2. So a sub 2 is 5. 5 plus 2 is 7. A sub 4 is 3 plus 1. So it's a sub 3. And our n is 3. So the one before was 7 plus 3, or 10. And the last one, a sub 5, 4 plus 1, 4. So it is 10 plus 4, or 14. Okay, that one kind of, if you sort of get it, and then you saw this one, you'd probably yell and scream. But just to give you an idea, it's still basically the same thing. They're still talking about the one before, but in a kind of convoluted way. So just so you're aware, I wanted to just show you one where they're subtracting, we're going back 2. So they have to give you at least 2 things to do this problem. This is like the Fibonacci Sequence, if you guys have ever heard of that before. Famous guy. Where we're going back 1, and then this one is back 2. So that's just saying a sub 3, okay, because we already have a sub 1 is 1. They've already told us a sub 2 is 2. So a sub 3 is back 1, back 2. So a sub 3 is 2 also. Then a sub 4 is this, this one right here means go back 1. So back 1 from 4 is 3, times 2 back, which is 2. So this is back 1, this is back 2. That's all that they're saying with those n minus 1 and n minus 2. So a sub 5, you're going to go back 1. Back 1 would be 4, and back 2 would be 3. So a sub 4 is 4. And a sub 3 is 2. Okay, that's it. Try the last one. I'm sorry this is going a little long. It's just recursive can be ecky. So anyway, try it out. Fast forward me till the end if you want. I'm just going to work through this one for those that want it. Okay? I'm sure I've already been fast forwarded, so it's all that matters. So this is 1 back, and this is 2 back. So a sub 3, so we already have these 2, is a sub 1 back, so it's a sub 2, plus 2 times 2 back, a sub 1. Okay, you don't have to write that out, but maybe that helps. So a sub 2 is 4 plus 2 times a sub 1, which is 3. Okay, so that particular one is, I can do math, 6, 10. I don't know why I have, oh, I multiplied when I did my key. Okay, so a sub 4, 1 back, plus 2 times 2 back. So let me put my 10 here. So 1 back is this one. So this is 4. So 1 back is 3. I'm going to write underneath just because. Okay, and 2 times 2 back, which is 4. So 10 plus 8 is 18. Sub 5, 1 back of 5 is 4. And 2 times 2 back, 5 minus 2 is 3. So a sub 4 was 18. And a sub 3 is 10. So it's plus 2 times 10. So that's 20, 38. All right. Sorry it's a little long. I'm sure you'll fast forward me anyway. Have a great day.